might always want to think about is that whenever you have four terms, no matter what the degree is, always look to see if you can group them. Always check to see if you can do a grouping problem. Whenever you have four terms. I know, right? Because now you're going, son of a. Because watch what happens. If I group these, what's the GCF there? What's the GCF here? Are those two terms in parentheses the same? Yeah. So you have x to the fourth minus 81 and 3x plus 1.
Wait, how do you know when to group? Like, how do you know
The trick is always check when you have four terms. Check and see if you can group with GCFs. It's a shortcut trick. It's even quicker than synthetic. So now is x to the fourth minus 81 factorable? X squared plus 9, x squared minus 9. It's a difference of squares. We're going to do more of it, so don't worry. Now in this case, I think this one was solved for all the zeros, correct? Now I can do that. I can stop and do all my zeros. I have plus minus 3i, plus minus 3, negative 1/3. What's that? Was it just real zeros? Okay. If it was just real zeros, then you don't have to worry about the I ones. Okay. If that one said real zeros, I wasn't sure. I just erring on the side of caution. Okay. That's how that one would work itself out. Now, if you went synthetic, it wouldn't have been too bad because you would have done positive 1, not work, negative 1, not work. 3 would have worked, and then you would have tried 3 again, it didn't work, and then you would have tried negative 3, and then all of a sudden you would have been left with the imaginary and the, what do you call it, the 3x plus 1. So it should have been terrible at that point. So yeah, the trick here is, guys, anytime you see four terms, try to see if you can group. What else do you do when you have 3 terms? What should you check when you have 3 terms? You can factor it how you would a trinomial. Remember, it's like x to the fourth, x squared, and a constant. X to the 8th, x to the 4th, constant. Always check and see if you can do it that way too. It's a nice little, one of those little trick ones. What else do we have? Any others? What's that?
The mysterious 54.
56? Yeah, I was going to say,
Run into a wall again.
it's a joke. She can hear you. It's too much.
No, 44.
Excuse me. So this one I can't do that simple trick because I've got 5 terms, so I'm not going to be able to do it. I'm going to actually have to list out all my possibles. But it's not bad when your tail's a 2 and your first one's a 3, so you don't have that many to work with. So you have plus minus 1, 2 over 1, and 3. So I really have to worry about plus minus 1, plus minus 2, 1/3, 2/3, plus minus 7. See what happens. Start with 1, 3, 11, 11, 1, negative 2. This is 56. Not going to happen. Yeah, it does. I got a 0. Yay! So if my 0 is at negative 1, what is my term?
It's 1.
X plus 1. So now I'm at an x to the 4th, and so it's 3x to the 4th, 8x cubed plus 3x squared minus, x cubed squared minus 2. If I'm looking at that as a 4-term problem, I'm not going to be able to factor that because by grouping, because I don't have GCFs that'll work. So then I just go again. I'm going to check again to see if I get lucky with the negative 1. Just to try. Yep, we will. When we got lucky again with the negative 1. So if negative 1 is a 0, that just means it's a repeated 0. So, oops. It's a repeated 0, so I'm going to have 2x plus 1s. Which means on the graph, what happens with this polynomial? It changes directions at negative 1. That's all it means. Okay. So now I have 3x squared plus 5x minus 2. So then I can check it. What times what is negative 6 that I add together to get positive 5?
6 and 1 somehow.
6 and 1 somehow.
I don't want to
Well-
think about like which way.
Honesty. So we get 3x squared minus 1x plus 6x minus 2. So you have an x, 3x minus 1. Take out the 2. So we wind up with then x plus, what's that?
Oh wait, no, I did do it right. Oh.
So you have x plus 1, x plus 1, x plus 2, and 3x minus 1. So my zeros are at negative 1, negative 2, and 1/3. This one is a repeated one, so I should probably write that down twice so I don't forget it. So remember, whenever you have a repeated 0, if I ask you to graph the rough sketch via zeros, all we do is this. Our tails for this problem, I believe this was a 4th degree. 4th degree, first one's positive. What are your tails doing? Up, up, and away is not beautiful. Yes, I know. I'm sorry. This is so mean to me. Negative 2, negative 1, and a 3rd. So if my tails are up, up, it means it's going to do this. How many changes of directions can we have in the 4th degree polynomial? Let's try again. 3. You got 3 changes of direction. 4th degree polynomial has how many zeros? 4 of them. Just one of them happens to be repeated, just fine. Oh, did I ever ask you guys this question? Pete and repeat were in a boat. Pete fell out. Who was left? Pete and repeat were in a boat.
Don't
Pete fell
say
out. Who
it.
was
We'll
left?
just repeat it if you say repeat.
Pete and repeat were in a boat. Pete fell out. Who was left?
Repeat.
Pete and repeat were in a boat. Pete fell out. Who was left?
Repeat.
P times 3.
Anyway, so it does this. It's moving down, changes direction. It does that.
W.
That's what it would look like.
My dad used to say that to me.
Okay? That's what it would look like.
Wait, you would graph it too?
If I ask you to. You can graph anything via tails and zeros.
I mean, on the homework thing, do we have to graph it?
No, but I'm pushing you to that because you might be asked to.
I messed up more than she did because I didn't even think that that was factorable. I didn't even think that that was factorable, so then I did it with like the quadratic formula, and that's why I got it.
Yeah, I did the quadratic formula.
That's okay, you'll get there.
Weird answer.
What about the other one when you had the higher degree polynomial?
That was fine.
Yeah. Oh, on the 6? Fifth degree polynomial. I have 6 terms. I don't believe I need any placeholders. Take care of the tails. 5th degree polynomial. First term is positive. What are the ends doing for your graph? First degree, 5th degree, so it's odd. First term's positive. Down, up. So it's plus or minus 1, 2, 3, 4, 6, and 12, all over 1. Do I need to write that? No. So you go through your synthetic. 1, negative 1, negative 7. Got 1. 0 at 2, so your term is x minus 2. I'm now at a 4th degree polynomial, So I check it one more time, same 0, see if it's duplicated. Yay, it's duplicated.
It did
You
what?
can go further.
Oh, it did.
And you can go further.
And now look at this. I'm now at a third degree polynomial. Look at your coefficients. 1, 3, 1, 3. That's going to be able to group, you'll be able to group that. Because what this is, when you see replicated values, this is just x cubed plus 3x squared plus x plus 3. You could factor that via grouping then. Take out the x squared. Take out the 1. So you wind up with x minus 2, x minus 2, x squared plus 1, and x plus 3. So you have zeros then at 2, replicated 2, plus or minus I, and negative 3.
I know I did this one right. I asked you to do the wrong problem.
Oh, well, I'm going to go on to the next stuff,
I
okay?
know, I know.
All right. Make sure your name's on that, send that one up, and let's get into the write the equation stuff real quick. It's actually pretty easy.
Can I do this tomorrow? Because
I know, calendars can't double check stuff, whatever.
no, like I did the homework from like.
That's all right, Billy. I get it. If people screw up.
So I just like opened to a page and it had like homework written down. I was like, oh, okay.
No, it's not the end of the world. So when we're working with these, oh cool, I was doing that. Nice. What I'm looking at doing today is working through writing equations that actually given you zeros. And this kind of boils back to the idea of the constant question that you're probably getting annoyed of me saying. If 2 is your 0, what's your term? So if 2 is a 0, what's its term? X minus 2. So then, basically, if I'm going to ask you to write a polynomial, if I ask you to write a polynomial given specific zeros, it'll look like this. Write a polynomial with given zeros, 2, negative 3, and 4. So what are your 3 terms?
X minus 2, X plus 3, X minus 1.
And then what do you think you do? FOIL. That's it. FOIL. We get x squared minus x minus 6 times x minus 4. We have x cubed minus x squared minus 6x minus 4x squared minus or plus 4x plus 24. And it turns into a combined like terms problem. That's it.
And then it's tails. And then
No, let's just write it out.
oh, you don't want us to graph it?
No.
Oh, it said. Oh, it says write an equation.
Oh, what I do? So x cubed. Oh,
Minus 5x.
where at? Here? Yes, thank you. I got it. I looked at the 4 when I was multiplying by 2. Sorry about that. Yes. Sorry guys. I got ahead of myself there. So x cubed, x squared, minus 6. I went too fast. I should follow my own rules. Slow your brain down. Does that look better? So guess where the wrinkle's going to be? Just imagine what the wrinkle could be.
It's
On your skin.
On your face.
Imaginary numbers.
On your skin.
Get it? Imagine where the problem can be.
That
There's
wasn't.
treatment for wrinkles.
What? That's great.
That was horrible.
No, it's not.
That was like the worst joke you've ever told.
on the
Didn't even
test,
make
if the
sense.
answer has like an imaginary number, and you put like imagine the value.
Imagine the value.
Real fast. I'm not going to multiply this out, but if I have zeros at 3, 0, and negative 2, what are my three terms?
X minus 3.
X minus 3.
What's the 0 for x? Good. If 0 is a 0, what's its term? X. Okay. That's all that is. All right. Now, if I go to this one, actually put this on a separate sheet. Go back. If I go to this, I have a replicated 0 at 1, which means that would have been x minus 1, x minus 1. You okay with that? Now, how do you get imaginary numbers?
You make them up.
Square root of a negative. So, could this also have been, what I want you to think about now is when you have an imaginary value, one of the things has to happen. No matter what, you have to have both a positive and a negative imaginary. They go in pairs. They have to. A lot of times the book or tests or things like that might only show one of them. Well, if there's a positive I, there has to be a negative I. They only work in pairs. They work in tandem with one another. So, what value gave you I? Right. This is always, when you have I, if you had this, that came from x squared plus 1. Because you had to take the square root of a negative. Okay? You had to take the square root of a negative. Now, one of the ways that you could have done that is you could do the same idea, that this is going to be x minus I, x plus I, and FOIL it out. If you do that the long way, you still get x squared minus ix plus ix minus I squared. Remember when we did imaginary stuff back in quadratics? Notice what happens to the middle term there. They cancel each other out. So you get x squared minus I squared, which is what is I squared? Negative 1. So you get x squared minus a negative 1, otherwise known as, that's where that comes from. So you can still FOIL the whole thing out, you just have to be cautious with your signs as we get into it. Okay? So now it's just a matter of foiling all of that out. Do I need to do that? I probably do because I screwed up last time, but can we get away with not doing it? You can do that?
Sure.
Practice left for exercise. Or proof left for exercise. You'll see that in textbooks later. Okay?
All right.
Okay?
Wait, how do you get the negative?
Huh?
How do you get the negative?
What negative?
The 1, 1, I, negative I. Like,
That's what was.
What's what we did? I FOILed it out because the middle terms drop. Becomes a difference of squares. So you get x squared minus I squared, which is x squared minus negative 1. So it's x plus 1. It's going back from about a month ago when we did that. We're just using some old stuff. We're going to do a couple more, okay? Let's try another one. So this is another setup.
X minus 5.
That's the easy one.
I got that one.
Now, again, imaginary numbers work in tandems with positives and negatives. So if there's a 2 plus 3i, there also has to be a 2 minus 3i. Now, again, you can kind of go through this the long form way. Kind of do the same idea.
Wait, wouldn't you do like 4 plus 3i? Because then it would, like, you would subtract 3i on the other side and then take the square root of both sides.
I'm
Wait,
getting.
no, wait, 4 plus 3i squared would be, wait, no, just, never mind.
If you use the same basic idea of these are zeros, some term created them. Well, the term that created these would have been x minus 2 plus 3i and x minus 2 minus 3i. Water. Oh, that hurt all day. Are we okay with that? All I'm doing is just rewriting like I did with terms, okay? I'm not changing anything out. I'm not making anything fancy or scary. All I'm doing is just rewriting them through. So, we'll move this comma out of the way real quick. Now, what happens here is where things can get a little weird.
Switch the parentheses.
Remember the associated property? You can switch the way things are grouped. The associated property of addition was A plus B plus C. If I group those two together, it's the exact same thing as grouping A plus B plus C. What I'm doing is moving things around, and all I did really on that secondary one was distribute that negative. Because now, if you look at it, that's a difference of squares. That's a difference of squares. Because, let me show you, have you guys ever seen something called U substitution? Okay, U substitution is something that we use a lot more later on. Probably maybe once or twice more this year, but you see it a lot more in pre-calc and then obviously a lot in calculus. U substitution is this. Let U equal x minus 2. What I'm doing is I'm taking something that looks like crap and making it look like something easy. That's it. I'm breaking down because x minus 2 is the same thing on both sides, isn't it? So if I do that, I'm basically doing this. U minus 3i, U plus 3i. That's a difference of squares with a lot less junk around it. That's all I'm doing. I'm just making it look cleaner. It's a great trick. It's called U substitution. Let U equal something. You don't have to use U, but that's what they call it. All right? So now if I FOIL that out, difference of squares gives you U squared minus 9i squared, which is U squared plus 9. What is U squared though? X minus 2. Which therefore you can FOIL that out and then add in the 9. That's what it's having you do. That's what it's having you do. Because this is x minus 2 minus 3i, x minus 2 plus 3i. This is nothing more than a minus b, a plus b. All I did is I using this little trick in algebra called U substitution, let something that looks like crap look like something that's easy. That's all it is. It's very, very simple, fast stuff. Okay? So now if I FOIL the rest of this out, what was our other zero from way back when? So this guy's still here. What we're going to do then we can FOIL it all out. We have x minus 5, x squared minus 4x plus 4 plus a 9. Go. Just add it all together. Let's see, x cubed.
And then it's minus 2x minus 2x.
What's that?
Because do you want
Yeah.
to factor those? in?
Yeah. So we have x cubed minus 4 minus 5. 20x minus 40 plus 9 is 31, I believe. Think that works. I miss a sign. The second 20 shouldn't be there, right? That's what I thought. Okay. I got ahead of myself again. Slow down.
It's just
I know, right? X cubed, 4x squared. 4x. I forgot 4x. That's what I did.
like something seems
Yeah, that's where it went. That's 20, and then we get the 9 on the end here. So then you get your It's that quick little U substitution trick that should make itself work it out. It's just a nastier way to write it.
Page filled up.
Let me try a cleaner one. Let me show you another one. The 4 and 4. Watch what happens when you do this one. Oops. So for this one, you start out with, you have 4i and 4i. That means you also have to have what? I think I screwed something up on that one. I think I missed a sign somewhere. I don't know where I messed it. Because you're right, it should end up on 5 rather than work out. It's like you pulled through my head here. You're right, because I did that. I wrote it out. I screwed that up. I should have foiled through here. No, because what did you guys put it at? You put it here, right? Because you put the u here, you FOIL out, you're still going to get u squared plus 9, right? So then you get x minus 2 quantity squared, which is x squared minus 4x plus 4. Yeah, not supposed to be tacked on the end. You're right. Okay. God bless you.
Mess it up again.
Okay. Here's what happened. This was all supposed to be one part first. I didn't even. This should have been a 13 here. What happened was this 9 is supposed to be part of this. So then if you put the 13 in, because this plus, it's plus 13 then, right? Now when you FOIL it out, you get x cubed. Oh, that was a bonehead move. And then it's what, 65? Yeah, now that makes sense because the tail has a 5 in it. You can divide it, you can factor out a 5. Duh. 9x, 33x, 9x squared, 33x, and a 65. Okay. So here's what I messed up. At this point here,
You're messing up already.
I screwed up. I tacked on the 9 at the end instead of the
That's,
U.
there's like 3 or 4 problems that I'm doing in fact I'm like, I can't figure this problem out. And I'm like, all right, don't do number 6. I'm like, oh yeah, I don't know what to do.
No, I
do this problem.
I did this like a total doofus. I did a U substitution step for polynomial out.
Okay.
And then when I tacked it in, I squared this, and then I foiled out, and then I added 9 at the end instead of putting the 9 in first. I just had half a cup of coffee and not fully juiced up.
Far from some stuff.
I'd offer you some coffee, but
We're just making rounds. I'm like, actually do all the work here.
yeah. Oh, by the way, Mr. G's doing really well.
Yeah, he has a
Yeah.
heart.
He's got a new heart. Can you imagine that took what, 5 hours, 5.5 hours? 5
Take
hours.
one out and put one in.
Seriously, it takes longer to change brakes on cars sometimes. Think about it. You go to the hospital.
Well, this is what I said. I said it took 5 hours to take the heart completely out and put a new one back in, but it took him an hour and a half to like clean them up and stitch them up after. So like,
I can only imagine the stitches. Is it a
oh
zipper?
yeah, all the way down.
It's chest spreader. And
Oh, yeah, they.
did they videotape it?
I don't think so. They busted his sternum, cracked his ribs. Oh,
5 hours.
They filleted him open.
Fillet.
Pretty much what it was.
It's crazy.
Couldn't you
Just
imagine like the feeling when you wake up?
But you know, just think about science. I mean, seriously, 5 hours.
You're out of
5 hours.
Saying that
Yeah,
It's
the
one of the
hours
longest
is
5
out.
hours of my life, but it was 5
Well,
hours.
yeah. No, but I mean, you just think about it in terms of, 5 hours. It takes you 5 hours to drive from here to St. Louis. Okay? In that amount of time, Mr. Gonzalez got a new heart.
High school golf is like.
In
over
Grey's
5
Anatomy,
hours.
they do that in 42 minutes.
Well, it's great. No,
I'm pretty sure they don't.
They do it really fast.
That's what my wife would say.
They like have
Have
a
a good
timer
one.
and everything.
Yeah. So.
So back to this one here, when you have a 4i, and notice it's duplicated, what also has to be there? How many times?
Everything
That's-
back.
So you have,
Quote.
you guys might actually be able to figure this out real quick then. If 4i was the 0, what term got you a 4i? Well, you'd have to take the square root of negative 16. So to take the square root of negative 16, you'd have to do x squared plus 16 and x squared plus 16. Not too bad on that. Let's hopefully I don't screw this one up. X to the 4th plus 32x squared, 256. Okay. No one's yelling at me, so it might be okay.
So sad.
For a change.
You got it right.
Now, the only other thing I want to show you guys today is how do you write a polynomial function given zeros? Yes, sir.
Why do you put negative 1?
What's that?
Why do you put negative 4?
In order to get an imaginary number, you have to take a square root over an equal sign. Whenever you take a square root over an equal sign, you get plus minus. The book gets lazy; they don't put they don't put the other opposite in there sometimes. That's all. So if there's one I value, there has to be the other I value. Whether it's a 4i, then it'd be a negative 4i. If they give you a negative 2i, there had to have been a 2i. If they give you 3 plus 4i, there has to be a 3 minus 4i. Things like that. They come in pairs. Because in order to get an imaginary number, you have to take a square root over an equal, which always means it's going to be a plus minus. Always. They're just lazy and don't write down the other. They're saving money on ink. Okay. So the other quick example I wanted to show you guys is how do you write a cubic function given ordered pairs?
I wasn't trying to be.
So you have ordered pairs of negative 3, 0, 2, 0, 5, and 0, and you have another point at 0 and negative 15. If I want to write a cubic function, that means what degree is it going to be? No, go ahead. To the third.
Gosh darn it, I would have been right.
Third degree, okay? So there's a generic formula for this. It's going to look a whole lot like intercept form from quadratics. Y equals A, and you have 3 zeros. Where P, Q, and R are the zeros. So basically, if you've got 3 zeros to a cubic, and you know another point, you can write it all out in this intercept form, if you will. Which means, what value do you think we have to solve for? A, just like we did before. It's very similar to the other stuff, just adding another 0. So in this case, you've got 3 zeros. You've got a 0 at -3, a 0 at 2, and a 0 at 5, which means my terms are going to be x plus 3, x minus 2, x minus 5. And this is now where the other ordered pair comes into play, because what are those? X and y. So you substitute in. Y is -15. So we have 0 plus 3, 0 minus 2, and 0 minus 5. Which means you have to multiply those 3 values together. Now, I'm no betting man, but I will suggest one thing, because I may have a sense that you could screw that up rather easily. Your calculator has, I trust you, but I want you to do well for yourselves. Your calculator has this crazy button on here called parentheses. I would highly recommend
Use them.
you use them, exactly. So what I would do in this problem is I would do my parentheses 0 plus 3, 0 minus 2, and 0 minus 5 to take out any possibility of screwing something up. Not to say that you wouldn't, but if I put that in like that, you're going to be hard pressed to screw up. I hope. So that means all that stuff multiplied together is 30. So I get -15 is 30a. What's your value of a? There you go. So then your answer then would have been y equals -1/2 x plus 3, x minus 2, x minus 5. In this instance, when it's asking you to write it in terms of a cubic function, you do not need to multiply it out, because this is the format we were just solving for an a value. Okay? This is a really easy one. I figured we could tack that on with the other ones. Won't be that big of a deal. Okay? Let me give you some props. Yeah, I'm good. I'm trying to get this real quick. Okay. Bless you.